In the first case, you were answering the question, what is the equation? And it's here somewhere, under here. There it is there, this top thing. What is the equation of that line when you know two things? You know one point, and you know what the gradient is. Okay? When that's the case, we go straight into using that formula there. Y minus y1 equals mx minus x1. Substitute everything in, there's our answer. Okay? The second part is, what if you're given, in fact I'll go back here, what if you're given this situation here? This point here is 2, 7, and this point here is 10, 2. And the question says, we've now got 2 points. What's the equation of the line that joins those 2 points? Okay, slightly different because our formula, y minus y1 equals mx minus x1, relies on you knowing what m is. But we don't know what m is because we've just got 2 points. But what can we do about that? We can just work out what m is because we know what the formula for m is. Gradient, rise over run. What was the formula that we used the other day? What did it say? Yeah, it's the difference between the y's, y2 minus y1 divided by x2 minus x1. And that's not y. That, of course, is the gradient. So in other words, when we've got 2 points, that's no big deal. The very first thing we do, we use y2 minus y1 over x2 minus x1, rise over run. That gives us the gradient. We work out this. What is the rise over run for this exact situation here?
Is it -5/8?
Yep, the difference between the y's is 5. So this bit here, I would just do it by looking at it. That is actually about 5, exactly 5 in fact, and this is 8, and it's a negative sloping line, so it's -5/8, exactly what you said. So -5/8 is our gradient. So therefore, which one are we going to use for our point to go with it? Does it matter? Shouldn't matter because a line of -5/8 going through that top point is going to go through the bottom point and vice versa. So therefore we just go to our formula and go, let's use that one just for the hell of it, the 2, 7. Therefore y minus 7 equals -5/8 x minus 2. We've just substituted into the standard formula, and we chose this guy, the top point here, as being our x1, but it makes absolutely no difference. And then we just rearrange this so that it's in one of the 2 formats. Here's a trick, something which you'll notice very quickly. If there's a fraction here, then general form is the easier of the 2. When there's a fraction, because the very first thing you should do with a fraction is multiply everything by the denominator. So you should then write 8y take away 7/8 of 56, which is -5x minus 2, like that. So I've just moved the 8, or multiplied everything by 8. I'm now going to expand the right-hand side. And then I'm going to have a look at this. Obviously that 8y minus 56 is also here. And now I'm just going to move everything to the left because it's convenient to move everything to the left because it's going to take my -5x and turn it into a plus. So it'll be 5x's, 8y's, and if I move 10 to this side using the change sign thing, then that's going to be -66, and that is the answer. And it's a hell of a lot easier with a -5/8 to multiply everything out by 8 than it is to try to rearrange this and end up with a y equals mx plus c. It's just tidier. So general form, I personally prefer general form just because it's consistently tidier. So there it is, equations. We've just started equations of lines. And really, there's point plus gradient. If you've got point and gradient, then you just use y minus y1 equals mx minus x1. Okay, so there's the first opportunity. If you're given 2 points, then you calculate m, which is y2 minus y1 over x2 minus x1, or just rise over run, and then use y minus y1 equals mx minus x1.
So why isn't m's gradient?
Sorry? M's gradient, yeah, m's the gradient. Because someone called it m, and it's just always been m. In fact, a long time ago I had a discussion with some people, a very long time ago, and I think we are the only ones who write y equals mx plus c. In Australia, I think they use a b, y equals mx plus b, or America or somewhere. But everyone uses m for gradient, and I'm not quite sure the historical reason for that. But it's basically completely arbitrary. So, 2 processes to get the straight line shouldn't actually be too bad.